Hey everyone, I'm very happy to be here today and talk to you about lessons that I learned while building Session Replay, which is a DOM capturing product that I've spent the last couple of months working on. And while I worked on this, there were a few things that I kind of had to dig really deep into, and where I figured, hey, these things are not necessarily just relevant for Session Replay, but they could also be relevant for lots of other contexts. So I hope that by the end of this talk, you've learned something that you can also maybe use in whatever you are working on today. So hi, I'm Francesco. I live in Vienna in Austria. It's a beautiful city. If you haven't been there, it's worth a visit. Previously, I spent more than 8 years working on web UIs, so building stuff with HTML and CSS and JavaScript. And since 2022, I work at Sentry, where I work on the JavaScript SDKs, which basically means that I now build tooling that other web developers can use in their applications. So a short overview of what I will talk about today. I will give a short intro to Sentry and Session Replay, just because it's important to kind of understand the context of what I will be talking about afterwards. I will explain how Session Replay works, because that's kind of what this talk is about. And then I will dive into 4 concrete lessons that I learned while working on this, which is how important it is to know your use case, why you should always expect the unexpected when you're working in the browser, how to optimize bundle size, and how to efficiently compress data. So yeah, I work at Sentry. Some of you maybe know Sentry. What does Sentry do? Very high level. The thing we're most well known for is we do error monitoring. So basically you add Sentry to your application, and if something bad happens in the user's browser or whatever, you will be notified about it. We also do performance monitoring, profiling, other stuff. And especially since a few months, we also do Session Replay, which I will talk about. So what is Session Replay? I mentioned that the core of what we do is error monitoring, and Session Replay is really an extension to that. I guess many of you maybe know something like this. You have a user coming to you and saying, hey, I went to your website, I clicked on this button, and an error happened. And you go in, you try to reproduce this, but you can't reproduce it. It works for you. So you ask the user, can you provide more details? What did you do? The user will likely say, I don't remember, or I did nothing. So you're not really closer to figuring out the problem. And the idea about Session Replay is that it can actually tell you, as the developer, what the user did leading up to the error, and to basically allow you to fix the error faster. So an important part of this is not just telling you kind of what the user did, but also providing tools that you are used to for debugging, which for most JavaScript developers is probably the dev tools in the browser, and have a similar experience. So like a console list of console logs, a network tab where you see the network requests and stuff like this. So this is kind of how Session Replay looks. If you look at something that has been captured as a developer, you can see kind of like how the page looks, the mouse movements and stuff like this, and you also get a bunch of other details like breadcrumbs, or can also see console logs and network requests and things like this. One important thing is that the replay, the reproduction that you see, is not a video, or it's not images. It's an actual reproduction of the DOM at this time in the user's browser. So you can actually go in and inspect this with the dev tools and see the classes and the styles and everything that has been applied at this time, and really hopefully figure out what's happening, the same as if you would be sitting next to the user and kind of debugging this. So how would you use Session Replay? We have an SDK that you can use for more or less any language. There's a browser SDK, there's a React, Vue, whatever SDK, and you initialize this and you set up Session Replay. And that's basically it. We will then capture stuff for you. So how does it work to capture what's happening in the browser? So we use a fork of RRWeb. That's an open source library that's out there, which handles most of the heavy lifting of capturing what's going on. The core of this is a mutation observer. A mutation observer is a native API that all modern browsers support. And basically, it will notify you when anything in the DOM changes. And based on this, we can actually create a diff of, okay, what was the DOM before, what has changed, and this can later be replayed, so you can actually see how the DOM changes over time. In an ideal world, a mutation observer will tell us everything that happens in a browser. This is pretty performant, and it's a native browser API, so it's very unintrusive to use that. The sad reality is that not everything that happens is captured by a mutation observer, so we need some other techniques to actually capture everything that's going on. And we do this by monkey patching, which I will explain afterwards. But this especially covers style sheet APIs, so if you're using something like CSS in JS, this interacts with some style sheet APIs that are not covered by a mutation observer. So we need to capture this in a different way. And also, for example, canvas APIs. So if you want to see what's happening in a canvas, we also can do this with a mutation observer. So what is monkey patching? It's a technique used to dynamically update the behavior of code at runtime. So in simpler terms, practically it usually means we override a global function with a custom implementation of a function. Now, this is inherently dangerous. If you can avoid to do that, you should avoid to do that. But sometimes there's no other way to realize things. So this is a very simple example that you see here. In Session Replay, we have a list of network requests that have been made. And we want to see basically all the fetch requests that a user did. It's not really feasible to expect the developer to manually add every fetch request they make to some list that is sent to Sentry. This should happen automatically. So what we do is we override window.fetch with a custom function. Then inside of this, we can do something. In this case, we just log something. In reality, we would kind of capture this to Session Replay. And then we call the original function to ensure that the actual fetch request happens. And yeah, this is an approach that we use quite a lot. I will dive later into the dangers and downsides of this. So now let me dive into some concrete lessons that I learned while working on this. I will start with talking about how important it is to know and focus on your use case, why and how you should expect the unexpected when working in a browser, how to optimize bundle size, and how to efficiently compress data. So first, know your use case. I think when building something, it's equally important to think about what do I want to do as what do I not want to do. So do we really need to do something? So what does this mean concretely, for example, in Session Replay when we built this? So when you've seen what I showed of Session Replay, maybe you thought to yourself, isn't this potentially very intrusive to kind of capture everything that the user does and have the developer look at this? And the answer to that is potentially yes. So when we kind of thought about this product and how this should work, we really thought about what is the use case we have? What is the thing we want to focus on? And for us, the answer was we want to help with debugging. We don't want to build a marketing tool, or we don't want to build an analytics tool. We want to help a developer debug a problem that a user had. And we figured for us specifically, for this use case, it's not really necessary to see the text on the page of the user. It's not necessary to see the concrete text the user enters somewhere, or even to in any way identify a user. So what we did is we decided that by default, all text on the page is replaced by asterisks, by stars. And for debugging, this is really mostly good enough, because what I want to know is the user went on this page, then to this page, and clicked kinda there, and then this error happened. I don't need to see exactly what the user saw. So we decided that the default is to hide everything. And the developer that adds Session Replay to the application, they can opt in to show certain text, if that's relevant for them, but the default experience is hide everything. And defaults matter, because most people don't change their defaults. So this also applies if you build a component for a component library or some other piece of code that is maybe used in different applications or whatever. Whatever you decide are the defaults is what most people will end up using. And another part of this is that it can also be helpful to think about things that should not be possible. So we want to make a code configurable and flexible and stuff like this. But some things maybe just shouldn't be possible. So in our case, for example, we decided there is no reason why a developer should ever be able to unmask a password field. We just don't see this. So we made it impossible to do that. And I think this is also valuable to keep in mind that not everything has to be possible. The next thing I want to talk about is that you should expect the unexpected, because when you work in a browser, you just don't have full control of the environment that the application will run in, and everything that can go wrong will eventually go wrong. So in our case specifically, we work with a lot of low-level APIs. We do a lot of monkey patching, as I mentioned before, and this is inherently dangerous. So what do I mean with this? Let's say in reality you would monkey patch fetch. How would you do that? We want to capture the URL and some other things that are like associated to this fetch request. So maybe I go to MDN and I go to the fetch docs and I see, okay, what are all the possible ways that a user may invoke fetch? You could pass just a URL or a URL and options or just options. So I go and I write my monkey patching code based on all the possible things I see in the MDN docs. And then I think to myself, cool, this code is bulletproof now. I covered all the possible cases. This will be mostly true, but if your code runs in enough contexts, enough browsers, eventually it will fail, because browser extensions exist, they can do anything, they do anything, and you will eventually have a user where, for whatever reason, fetch is invoked differently, and your code wasn't prepared for this, so your code breaks, and then a user gets an error from our code that they added to the application to the error monitoring, which is not cool, obviously. So you should be prepared that when monkey patching or doing other low-level stuff, anything can happen. Concretely for us, this means that we try catch everything that we do there, because in the worst case, we will not capture something, but at least no error will bubble up. I think one other important thing is that this also applies to using global APIs. For example, maybe you don't care about Internet Explorer 11. Hopefully, most of you don't have to care about this anymore at this point. But even when you go to like MDN or Can I Use, and you see like, hey, this feature I want to use should be supported by all the browsers I'm targeting, there will still be possibly cases where this is not the case. Sometimes things can be disabled in the browser settings or whatever. So it's still important to build things in a way that even if something fails, if something is unavailable, your whole code will not blow up, but it will just ignore the specific part and move on. Yeah, the next lesson I learned, and this was a long lesson, is how to optimize bundle size, because obviously we want to ship as little code as necessary to our users. So session replay is relatively complex. It does quite a lot of things, because there's so much going on in the browser, there's just a lot of code necessary to capture everything that's happening there. Some versions ago, the session replay SDK was like 53 kilobytes of minified and gzipped code, which is a lot. So we basically said, hey, this is kind of not acceptable, we need to get this down. So I spent quite a long time investigating how we can actually reduce this without reducing the functionality we have. So some versions later, we were down to 35 kilobytes, which is still quite large, but I think for what it does, it's an acceptable size now. So how did we manage to reduce bundle size by quite a lot without actually reducing functionality? So there were a few things we did. First of all, as I mentioned before, we use a fork of RWeb. So RWeb is a pretty big library that can do a lot of things. And the first thing I did is I went in and forked this and removed parts of the code that we just didn't use. So for example, there were some options and some functionality that was just not relevant for our concrete use of RWeb. And by removing this, we could save some bytes. Nice. Another thing we did is I audited the dependencies we use, because we had a bunch of dependencies that worked quite well. However, we figured for some of these there were actually alternative dependencies that did kind of the same thing, but with a lower footprint. So it's good to every now and then go in, take the time and look over the dependencies you have and kind of verify, is this still the best choice, or is there maybe a more lightweight alternative that you could also use? And finally, we made a bunch of recording features opt-in, which we did by optimizing for tree shaking. So what is tree shaking? Tree shaking is the ability to automatically remove unused or dead code from your application build. So concretely, that means if you use a bundler like Vite or Webpack, when you build your application, this bundler can look at your application and see all the code of dependencies that you're not actually using in your application. And it does that mostly by looking at imports that you have and by identifying imports that you're never using, and thus this can be completely removed from your build. So you remove code that you're not using anyhow, which is great. However, not all code is equally tree shakeable. So let's look at this simple example. Let's say in my library or SDK, I have a large and a small function. And I have a function that is large or small that takes some options. And based on these options, I call the large or the small function. Now, if in my application, I import this large or small function, and I call it with useLarge false, I, as a human, know that we're actually never needing the large function. So in theory, we could remove it from our build. However, for a bundler, this is very hard to know, because it can't really be sure, will this never be called with useLarge true? So this code, even if I know I'm never using the large one, the large function will still be included in your bundle. So if we want to make the same example tree shakeable, what we would do is we would just directly export large and small. And if in this case I simply import small and call this, then the bundler will know, hey, we're never using large, we can remove this from our application. Great. So let's look at a slightly less artificial example maybe. This is something that we concretely did. Our web has a record function that takes a bunch of options. So you can configure what do you want to record. And one of these options was record canvas. So you can say record canvas true or false if you want to record what's happening in a canvas on your page. Now with this code, if in my application I call record with record canvas is false, even though if I know, hey, we're not capturing the canvas, we could remove the canvas recording code, the bundler doesn't know that. So even though our default was that we're not capturing canvas, with this code, all users always had all the canvas code included in the application, which is not great. So we changed this to a more tree shakeable pattern, which is on the left side, you see, instead of passing record canvas as a Boolean option to the record function, we actually pass a getCanvasManager function to the record method. We export a getCanvasManager method, which kind of does all the setting up canvas stuff. Now, with this setup in my application, on the top section, you see an example where we're not using canvas. We would just import record and call this with getCanvasManager as undefined. And in this example, all the canvas code would be tree shaken away and removed from our build. On the example below, we are importing record and getCanvasManager, and we're passing this to the record function. So we know we need this code, and the bundler will leave it in your build. So with this pattern, it's really possible to have default experiences that are small, and users can opt in to more complex stuff by adding more config. This is something that is also not necessarily just relevant for libraries. It also applies, for example, if you write code that is only for testing or only for development environments. By using tree shakeable patterns, you can also be sure to get rid of those in your production builds as well. So the last thing I want to talk about is how we efficiently compress data. So session replay captures quite a lot of data. We need to capture all the snapshots, all the diffs of what's going on in your page. But we want to avoid unnecessary network traffic where possible, because it may be expensive, or it may be slow even, right? So we figured we would like to compress the data before we send it over the network. And what we do is we use a compression library and do something like zlib to compress the JSON payloads before we send them. And then on the server, we can decompress them, which works quite nicely. However, compressing large payloads is quite CPU intensive. And people add session replay to their application, and they don't want their application to be slow or laggy because compression takes up a lot of resources. JavaScript is single-threaded, so everything you do runs in one shared thread. So if the compression is slow, everything will be slow, and that's not great. So what we decided to do is we do the compression in a web worker. I will explain later how we do that. This works quite nicely. A web worker is a web API where you basically have a separate thread where you can run JavaScript in. So if this is slow, it will not directly interfere with the main thread where your application runs in. This is nice. This works well. However, like Asterix, this also increases the complexity, right? Because you need to communicate with the web worker over an interface. This gets asynchronous, something can go wrong. So this doesn't come for free necessarily from a perspective of complexity, but it can be very helpful when you're doing like CPU-intensive stuff, not just compressing data, really. One last thing before I dive into how to set up such compression with a web worker is that if you want to do compression, make sure to compare the libraries that exist to do that, because there are a lot of libraries to do that. And they vary a lot in functionality and bundle size. We ended up using Flate, I don't know if you pronounce it like this, which works quite well. But if you do that, make sure to look at different options, because maybe not everything that a library offers is something that you actually need. So how would you set up a web worker for compression? A web worker is a separate JavaScript file that you would host on your website. So let's say your website is www.example.com. You would have a web worker maybe at www.example.com/worker.js. So it's a separate file hosted. It has to be hosted on the same domain as the main script that is calling the worker for security reasons. So this would be a simple worker script. Let's start at the bottom. A worker can interact with the main thread, with your main application, over messages. So in the worker, we can add an event listener to messages, which would be incoming from the application. And then we basically call the handle message function. In there, we get some data, which is passed from the main thread. And what we use here in this example, we use an input and an ID. We compress the input, and then we use post message to send the compressed data back, and we also mirror the ID back. I will show in the next slide why the ID is important. So we get the ID and we just return it back. In the main thread, in your application, you would interact with the worker something like this. So first you initialize the worker, where the path is really like the path on your domain where you would find this worker. And then what we want to have here as an outcome is we have a compressed data function that takes some data, and it returns a promise that resolves with the compressed data. So this has to be async, because post message has no response. We just send data, and at some point we may get some data back. But we don't really know how this request and response kind of things are connected to each other. So this is a very simple pattern to kind of handle this, which is this. At the bottom, you see we post a message where the ID is a randomly generated ID, and we send the data. We also add an event listener to the worker, which will listen to stuff that the worker sends back to the main thread. And then in this listener, what we do is we check if the ID that I'm getting back is the same ID that I've been sending. And if they match, then I can basically say, hey, this is kind of the response to what I sent. So with a pattern like this, you can kind of have a request-response pattern with a web worker. You can do the same for other stuff. It's not like restricted to compression. Anything that's CPU intense, you could outsource it to a worker. Now, Obviously, this is very simplified. In reality, you would want to have a timeout probably, because what if you never get a response? What if something goes wrong? You probably want to add some error handling, but you can add this on top of this, and this should still give you kind of like an idea how to get started if you want to have a compression worker or a similar worker. Yeah, that's it basically. Everything I talked about is on GitHub. This is completely open source. You can look at it. You can be inspired by it. You can see all the issues and bug fixes I made for it. Feel free to look at it, leave feedback, whatever. I hang out on GitHub the whole day. And yeah, if you have any questions, we can do questions. Also, I will be around. I have a bunch of Sentry stickers too. If you want some, hit me up. I'm happy to hand them out. Thank you.